Today we're going to have some fun with embedded systems with Arduino, with the cloud, some cute little robots. You'll see, it'll be fun. Hey everybody, welcome back. Today's video is, well, we're going to do things a little bit different, but the driver behind today's video is an issue that I see coming up a lot with embedded systems, and that is that as people are trying to get into it, they come in not only with a wide range of skills, but also a wide range of goals. And you don't see this too often when people are trying to learn C and C++. I mean, there's a little of this, but in general, people learn C and C++ because they want to learn how to program, they want to learn how to create software of some sort, and they're trying to pick up the basics of the language. But when people come into embedded systems, they may be trying to become an inventor, a great embedded engineer, or maybe they just want to get something really simple working, like maybe they just want to be able to, say, turn the lights on and off with their phone, like that. So today I thought we would talk a little bit about the different options that you have available to you out there and have a little fun while we're at it. And we're going to get some help from Tuya Smart. That's today's video sponsor. If you haven't heard of Tuya Smart before, it is a global developer platform that makes it easy for you to create, deploy, and communicate with whatever device you want to create. The platform provides both standards, interconnectivity technologies, and hardware tools that connect the Internet of Things. And we're talking about hundreds of thousands of developers and their smart devices in 1,100 different categories. So this platform is big. Now in this video, we're just going to scratch the surface about what Tuya Smart could do for you, what the platform can provide, but I'll put links down in the description. If you're interested in making or deploying smart devices, you should definitely check it out. Also, I mentioned the Internet of Things. Maybe you're wondering what it is. Don't worry, nobody knows. The definition can change dramatically depending on who you're talking to and what they are selling. But whatever the IoT actually is, I love it. And it's really all about connecting stuff, your stuff, all your stuff, basically connecting everything, everyday objects to the internet so that we can get them to play together in interesting ways. And you older folks out there might be saying, hey, isn't this just distributed computing or ubiquitous computing or pervasive computing? And yeah, it is. Welcome to the world of rebranding. We just call it the Internet of Things now because it includes things like light switches and toasters. But anyway, Tuya sent me a bunch of different toys to play with, like this little robot that I'm using to turn my lights on and off today. And so I thought we could play around with these, have a little fun, and help you understand some of the different options that you have, because some of the options have been evolving quite a bit in recent years. And as I mentioned before, link down in the description to the Tuya Smart platform. And also they've provided a really cool offer, which we'll talk about in just a minute. But now let's just jump into our options. What different options do we have available? So the first option I want to talk about is basically the option where you don't have to write much code. Now I know this channel is usually full of code. We tend to go for the code everything from scratch option always. And of course, I'll talk about that option in a bit. But sometimes you just want to be able to flip a switch. You want to just push a button really quick and you just want to get something working. You don't actually care how it worked under the hood. And for that option, let's take a look at this little finger bot. So this is, well, I don't know if it's the world's cutest little robot. It's the cutest little one I've ever played with. Basically, the reason it's called fingerbot is it basically is here to just replace your finger. It just has this little arm that can move up and down. It can push a button. It can flip a switch. It doesn't do anything too complicated, but just simple things. And this little robot was developed by Adaprox using Tuya's Bluetooth Low Energy SDK, which is basically just a toolkit that they've provided to try to make it easy for us to develop Bluetooth Low Energy devices, or BLE devices. So let me show you how I go from something like this to getting something working like automation in my home where I can, connect my phone to a light switch. Because this is probably the easiest embedded systems project ever. So before I started making this video, I installed the Tuya Smart app on my phone and I created a free profile. Then I charged up my fingerbot. It wasn't dead on arrival, but I'm paranoid. I charge stuff up, so I charged it anyway. And then I just turn on my fingerbot and click the little plus sign up here to add a new device, and it finds it. Okay, so one thing to note also is that you can manually add devices. There are a lot of different supported options out there and a lot of different supported devices. So while I may be switching lights today, there are a lot of other options. But so now once I'm done adding the fingerbot to my phone, then I have access and I can just control my little robot like this. And of course, the app gives me a bunch of different options, things like how high up I want the arm to go, how far down, and it has a switch mode down here where I can decide whether I want, where I'm operating a switch or whether it's a button, like a momentary button where I just want it to go down and up or, something like that. And this really allows me to turn on just about anything, light switches, for people like me who don't have smart lights yet, but want the pleasures of smart lights. And of course, the current version does make a little whining noise, so they need to make a quieter version. But the point is that these days, you have a lot of devices that you can buy that are basically ready to play. We didn't have to write any code and we just got the job done. And for a lot of people out there, maybe that's the right move. Now, I know at this point, a lot of you are starting to get a little twitchy and being like, but I want to write some code. It's okay, I hear you. So let's move on to option number 2. Because these days, platforms like the Tuya Smart Platform make developing a new device and connecting it up to the cloud a whole lot easier than it used to be. They provide a lot of the networking glue that's going to be the same for a lot of different devices. So if you have an idea for some device, a sensor, a toy that you want people to be able to connect to their phones or to the cloud, Tuya is going to make your job a lot easier as a developer. Because say you're not looking for an off-the-shelf solution, you are trying to design a new device, a new something that needs some customization. You don't just have some off-the-shelf option that you want to go with. You do want to change some things up. You want to customize some behaviors, the look and feel, whatever. Maybe you have a preferred form factor, I don't know. But the point is you want to customize things. And you could, of course, just say, let's go do everything completely from scratch, but that's going to be a ton of work. We'll talk about that in a minute. But maybe you're in a hurry, you want to get things up and running quickly, and maybe you're not feeling quite ready to start developing custom firmware and custom hardware and everything that comes along with that. So in this case, we have a second option, which I'm going to call our platform supported development option. So with this option, we can basically use components that are supported by the platform. So components like this is a microcontroller with Wi-Fi and BLE built in. And this is built into a nice convenient board that I'll demonstrate in just a minute. But the nice thing about this little module here is that we can find a lot of code already existing. Tuya will actually just give us firmware that will allow us to quickly connect up whatever I connect this board to, whatever I connect this module to. I can easily connect that up to the cloud. I can connect it to my phone, to my laptop, basically any of the Wi-Fi or BLE devices that I have available to me. And this is going to help you prototype devices and get them up and running quickly. Now this is a development board. They call them their sandwich boards that Tuya sent me just to play around with and see what I could do. You will notice that it's a very convenient size. So it just happens to be the right size let me find it, for an Arduino Uno. And that is to allow me to basically just connect these things together like this. All right, so we'll just plug in. That's convenient. We're going to use that here in just a quick demonstration. But so this allows me to take advantage of the benefits that I get from the Tuya platform while writing some of my own customized code in Arduino in this case, but it could be any microcontroller that I'm playing around with. And it allows me to customize my device without having to reinvent everything. So let's look really quickly at how this works. So I'm going to be using my Arduino Uno. I'm also going to be using this MCU board that I got from Tuya. So this is going to be running some firmware that's going to take care of my Wi-Fi connectivity for me, help me connect up to the platform. And I'm also going to be using this socket board. Now note that these are boards that Tuya sent me. These two boards specifically are only currently available in mainland China. But both boards are pretty straightforward, and this board particularly is simply just an adapter around this module. And I put a link down in the description. Click on that link. Hey, Future Jacob jumping in really quick just to clarify things, to make sure that none of you get confused. So Tuya Smart has offered a gift to any of you that click on the link down below. Basically, you just click the link, you register for an account on the platform, and then send email to dev@tuya.com, and they will give you a developer gift worth $7.50. So check that out. Hopefully it helps you get started and up to speed quickly. All right, now back to the video. So it's an easy way to just try this out, get your own module, and play around with it and see if you like it. So be sure to check that out. Now about this socket board. It's called the socket board because it contains everything in it that you would need to make a smart electrical socket or light socket. So it has connectors here and here that allow you to basically send in input power and output power, and it has a relay here that's basically just going to control power between these two. Now don't worry if you've never seen relays, they're pretty simple. They're basically an electrically controlled switch. It typically looks something like this with 4 pins. These 2 pins are the power path. This is what we're controlling. And when the relay is engaged, when it's connected, then these pins will connect to each other and electricity will flow from one end to the other. Now these other 2 pins are going to control the switch. So if we pass current in one of these pins and out the other, the amount of current is of course going to depend on the relay, but if we do that, then the switch will engage. Once current stops flowing, then the switch will disengage. Maybe it's a plus, maybe it's a minus about relays, is that when they engage, you're going to hear a little click. Now, there are a lot of different variants on this idea. Some relays latch, others have multiple switches and multiple channels, and you also have solid-state relays that don't click. Let me know if you want to talk more about relays or other hardware components in the future, but for today, this should do. Okay, so I have connectors to supply 2 wires over here, and of course the power comes out over here. And if I engage the relay here, then basically whatever it is that I'm connecting up here is going to turn on, and when I disengage it, it's going to turn off, and I'm going to be able to control that from my Arduino. So this is really a pretty simple circuit. It's a pretty simple board, but there's a lot I can do with it. And this little switch here is connected to Arduino pin number 7, and we are going to use that in our example as well. We'll get to that in a minute. And note that I could make my own board here if I wanted to do something other than just control a relay that regulates power to something. I have a few other videos about making boards. Check those out if you want a little more information on that topic. But for now, that's my hardware setup. So let's jump in and take a look at the code. I'm going to be using the Arduino IDE today just for simplicity. You all know that I'm not a huge IDE fan, but I know a lot of you Arduino users out there use it, and it's going to make today's example really simple. So that's what we're going to use. Now, before recording, I also installed Tuya's Wi-Fi MCU SDK library into Arduino, and this is what I'm going to use to connect the platform. And if we look up here, the SDK comes with a few different examples. So if I come all the way down here, you can see the SDK, and we're just going to use this start one. Rather than write everything from scratch, we'll just start with this example. Expand it so you can see everything. Now there is a bunch of code here. I'll walk you through it. It's really pretty straightforward. We have some header files up here up top, and then we got a few variables here. The first is an object called myDevice that I'm going to actually use to interact with the Tuya SDK. LED state down here. This is just keeping track of the state of the built-in LED on my Arduino board. The example is going to use that for letting us know when it's connecting and also when the switch is turned on and when it's turned off. Key pin is just recording that the button, the one I showed you on the board, is connected to pin 7, so we're just keeping track of that connection right there. Next, we have this DPID switch 20. This is defining a data point. Now, this is a logical connection between the platform and our device. I'll show you in a bit how we specify data points, and I'm thinking we'll change this 20 onto something else. Yeah, let's make this a 0. I don't really care. Maybe 1. It doesn't really matter, it's totally arbitrary. Then down here, we're gonna put our data points in an array. So right here, we've just got our array. In this case, we just have 1, but we could have more in a more complicated device. And we put them in this 2D array where each row is a data point number and the type of data point it is. So in this case, our switch is going to be a Boolean, basically on, off. So it's either going to be true or false, specifying that right here. Then down here, we have our PID. We're going to update that later. This is going to specify our platform ID for the device. And then also down here, we have our MCU version. That's going to describe the version of the microcontroller that we're using. And we're going to have to change both of these to match our setup. We'll get to that in a minute. And then our last variable down here, this is going to be used for some timing information. Nothing complicated. It's just an unsigned long. Now, if we slide down here in the code a little bit in setup, you notice that we're going to start up our serial connection at 9600. I'm guessing the SDK uses that for communication. I'm not sure why there's a commented out version of the same line. I think just to avoid annoying myself, I'm going to remove that. Then down here, we set up our LED, basically setting the pin that the LED is connected to as an output. And then we're going to start it off low. So we're basically going to turn off the LED. Next, we want to set up our key pin. That's going to be an input with a pull-up resistor. Now, if you haven't seen pull-ups before, that just means that it will be pulled high unless someone else drives it low. So it's sort of providing a default value. So unless someone's actually pressing that key, touching the switch, then it's going to be high. When we press the switch, it's going to be driven low. Then we're going to initialize the SDK right here, telling it what our PID and MCU version are and what our data points are. That's right here. We're basically just going to say, this is the data points that I care about. Then down here, we're going to register 2 callback functions. Now, I've shown you a few different callbacks in other videos, but the idea is simply that we're telling the SDK, hey, when something happens, call this function. So in this case, we have 2. The first one is called DP process. That's going to get called whenever one of our data points changes. And then we have DP update all, which is going to allow us to send updates about all of our data points. And then we're going to grab our time in milliseconds, and we're going to use that later. So now if we come down here into loop, remember loop is sort of like Arduino's version of main. It's basically the Arduino program's main loop. So in here, each time through the loop, the example is calling the UART service method. Now, I'm admittedly not 100% sure why. I'm not sure what this does, if this is just like the check-in does some communication. I'm assuming that it's checking in with the MCU board to see if there's any updates. But after that, then what we're going to do down here is we're going to check the key pin. Okay, we're going to see if the button is pressed. And if it is, if it goes low, then we're just going to wait and we're going to check again, which might seem weird to some of you. They're basically just wanting to make sure that we really pressed the button and there wasn't some sort of little glitch, because buttons can be finicky. Anyway, if the button is pressed for at least 80 milliseconds, then we're going to put the MCU board in Wi-Fi mode. So that's basically what this is doing, is just putting the MCU board in Wi-Fi mode. Then this next code right here is basically just checking a bunch of different conditions. I'm going to spread this out so you can see all of it. Basically, is it low on power? Is it connected to the cloud? Is it in some unknown state? And while it's trying to figure its stuff out, it's going to turn the LED on and off, letting us know that it's connecting. And here, you remember this last time that we used, it's basically just using that to do the blinking. So as we keep checking, anytime the state changes, well, that can affect it. But as time passes, every 500 milliseconds, we're basically going to update the LED state. And then once that's done, interestingly, our example is mostly done. So let's come down here and look at the two callbacks. Also, I didn't mention, but there's a delay here. That's just, it's really common in Arduino programs. It's basically just adding some delay so we're not burning too fast. We're not checking things super fast. We're basically just giving it 10 milliseconds to just like chill out a little bit. So now let's come down and look at our callbacks. We have DP process here, which has 3 arguments. It has our DP ID, which is telling us which data point we're dealing with, and it has an array of bytes. Also the length of that array right here. And then if we come down in here, you basically just have a switch statement below. So this is going to be called anytime we get an update to one of our data points. So the switch is basically just checking which one of our DPs, which one of our data points we're looking at. So in this case, we just have the one. So if the data point that we're looking at happens to be our DP switch, so basically what we're going to do then is we're going to grab the state of that DP. We're going to get the true or false value, and that's going to return our LED state. And then right now, what this example is doing is it's just turning on the LED if the DP is set to true, and otherwise it's going to set it to low. So it's basically turning the light on and off depending on the state of this data point. And then after we're done, then we're also going to report back. We're going to send back, we're going to call this MCU DP update. In this case, I'm just reporting back the same value that we got. If something happened in here, and let's say we needed to say, no, the data really is false when you said it was true, then we could try to report that in here as well. Then if we come down here to our second one, to our DP update all, really all we're going to be doing is calling that DP update function again, and we're just setting our LED state. So this is in case the SDK wants to know what should the LED state be, then it's just, in this case, going to let the platform know this is actually the state it's at. So that's the code we're starting with, pretty straightforward. Now, before we start making changes, let's just get things connected with the Tuya platform. Okay, so if I'm in the platform really quick, you can see I've played around with a couple of things. So in here in the platform, let's say I want to create a new device. I just click create. It's super easy to set this up. You can see there's a whole bunch of categories here that I can select devices from. Today, let's just look at a simple one, this socket right here. We'll just say, let's make an electrical socket. There are, of course, some no-code options. I'm just going to select this custom solution and select plug. It's simple. But you can, of course, select whatever option works best for you in the project that you're interested in. Let me give your product a name, my product name. You could give it a model as well. I'm not going to bother right now, but then you just click create. And then this brings you into a setup where you can select which data points you actually want to add to your product. So you could just say, I want 2 different switches or things like that. Let's just stick with 1 for now. And then we say, okay. Then you would click over here in hardware development, and you actually take this, you sort of this logical device you're creating, and you select how you're going to interface with it. I'm going to use the MCU SDK. And then I can come down here and say, well, which module am I using? And the module I'm using for this project and this demo today is the WB3S Wi-Fi and Bluetooth module. So I would select that and say select. And that basically just tells it that this is the thing that's going to be driving this device. And that's basically how I set up my device. You can see here, you get the firmware name, and you also get the current version. So that's basically how you would set up your own device. Of course, you can customize it to whatever you want your device to be like. Now let's jump back in, because I'm actually going to use a different one that I set up, but set up in the same way. So let's jump back into this overview page. If we come down here to my test socket, this is the device that I was kind of playing around, and I based it on a smart switch, a smart power socket. That's where you can see the icon right here. So in here, the platform makes it really easy for me to basically create new devices. If I come in here and say continue to develop, let's just come in here and see what I'm setting up here. Okay. Now, when I set this up, I specified the hardware module that I was working with, and it was super simple to set up. I just specified that I wanted to use the MCU software development kit, or SDK, and I specified what Tuya module I'm working with. In this case, it's the WB3S Wi-Fi and Bluetooth module. And you can see this information right up here. And you'll note while we're here that there is a PID right here. That's very handy. Let's copy that and go put that in our Arduino code. We'll come up here and we'll replace that. Okay, so we have our PID. And if we come back here and we look in hardware development, so you can see here's some more information about here. Now, one thing you're also going to notice is that my MCU version is 1.1.80. So let's make sure we update that as well. Yes, let's save this as something else. My start. Okay, great. So that's helping me update my software. Now, if we come over here, if we go up to function definition right here, this is where we're going to define how our device actually works. You notice that this is where I define my data points. In this case, I just have one, and I I called it switch one. It's a send and report, meaning that I can send this and also the device can report it. It's a Boolean. And so we can edit this information, but this is basically what I want for this example. And I set the ID to 1, which we come down, it looks like, did I get that right in here? Yes, so I did set DPID switch to 1. Originally it was 20, and whatever we set it in the cloud, we set it to here, it's gonna be fine. We just have to make sure that those two agree. Now, as I mentioned, there are a lot of other data points that I could specify, a lot of different types, depending on what sort of device I'm developing. But for this example, this is going to work. I'll leave you to explore some of those other possibilities. Okay, so if we jump back into our code, we updated the things we needed. We updated our data point and we updated our PID and MCU version. So now we're going to add some code to actually interact with the socket board. But first, let's just program the Arduino and make sure that things are actually connecting. So what I'm going to do is I'm just going to take this code, I'm going to plug it into my machine, and let's just compile it, make sure that everything is looking okay. Okay, so it compiles okay, and let's just put the code, we're going to put the code onto our Arduino. Okay, so we're done uploading. Now what I'm going to do is I'm going to unplug my Arduino because I'm going to attach my Tuya board to it like this. Note that when you're plugging boards together, you typically don't want things powered. You can have all sorts of problems, especially if you plug something in the wrong way. But so yeah, so basically I'm going to plug these together now that I've put the code on the Arduino right here. And now what I'm going to do is I'm just going to plug this into the USB. Now this is just for power purposes. We're not actually sending anything to the laptop. I'm just doing this to supply power to the whole thing. And of course the USB could be used for debugging purposes, but right now we're not doing any of that. We're just supplying power. Okay, so now I have my 3 boards connected and I'm getting power from the USB. We could of course power this with a battery or solar panel or anything else. But now if I come into the app, you can see it right here. If I come into the app and I click the add button, you can see then it's going to bring up, it's going to find my device. It's going to say, hey, there's one to be added right there. It discovered my device that I've got plugged in. It automatically discovered it. And so I can say, go to add. And you can see it's basically adding this test device. It's got a little progress bar that's going through and basically downloading the firmware, I'm assuming, or there you go. It actually, now it's fully connected. And if I click next, then basically it's going to say, yes, it added the devices successfully. And we're just going to click that done button. And now I have a really simple interface here for my switch where I can switch things on and off. And you can see when I switch it from my phone on and off, you can see that the little LED on the board turns on and off. Okay. So yes, I did just find another way to blink a light. Why is it that all embedded systems projects seem to be about blinking lights? But yeah, so this allows me to control through the cloud from my phone. I'm able to turn this device's light on and off, and that's happening through my Arduino code, which is interacting with the module. So that's super easy and it's cool, but the point of this whole thing was we actually wanted to use the relay to cut power and actually like control something. So let's jump back into the code and let's add some code that makes it actually engage the relay, because blinking lights is fun, but that's not where we want to stop. So this is going to be really straightforward. All we're going to do is come in right here in our variables. Let's just add one more variable. And let's say this is going to be relay pin. And you remember that was connected to pin 10 on the Arduino. Also, while I'm at it, let's just make this const as well, because it's not going to change. And let's come down and set up, and let's basically just take this code and duplicate it. What we're going to do is we're going to initialize the state of our relay. And so what I'm going to do is say right here that my relay pin is going to be an output. We don't want any pull-ups or pull-downs. Also, in case you're wondering what I'm doing, we talked more about digital inputs and outputs in previous embedded systems videos, so check those out if this is at all confusing. But then the only really thing to do now that we've specified the pin is we can come down here into our code where we're actually changing the state. So down here, this is where we actually turn things on. turn things off. And then really all I need to do here is come down here. We'll leave the LED just so we can see. That may be helpful if anything goes haywire, but we just say my relay pin, we're gonna make it go high, and that's gonna cause current to flow through that relay, through the relay pins, which is gonna turn it on and off. And then similarly, we can make it go low when we turn the thing off. So now if I come back, I'm gonna unplug things. Again, remember, we want things to be unpowered when we are actually messing with connections. That way I can remove these boards because I don't wanna try to program them at the same time. Plug it back in, and then we're going to reload our code. So we'll recompile the sketch. Hopefully there were no mistakes, and we'll get the new code on here. Unplug it, remove power, and then we'll just plug this back in and plug it back in. Okay, so now we have the new code on the device, and hopefully it's gonna control the relay. Let's get my phone out and let's just see what happens. Now we're doing the same thing, so we should still see, if we look in here, we should still see the same LED engaging. But if I click this, you notice that, so the light is going on, but you can also hear, I'll put it up by the microphone a little bit, you can hear there's a little click every time. That's the sound of the relay actually engaging. So this actually is controlling the power connection here. So if I plug this into a light switch, a toaster, an alarm clock, basically anything that I wanted to control, now I have a phone-controlled smart device. Now, obviously, there's a lot more we could do with this platform, and honestly, after some of the projects that I've worked on and how hard it can be to get things talking, especially over Wi-Fi, especially with devices and services going on in the cloud, this actually sometimes feels just a little too easy. But still, it's awesome, so please check it out. Link again down in the description. Any of you that are interested in getting something up and running quickly, please show our sponsor some love and check out their platform, because it's really cool what you can do in a very short amount of time with very few resources. Because this approach gives you a lot of different things you can customize, but it also allows you to get things up and running in a very short amount of time, can save you a ton of time. Now, of course, I see this as an in-between version. There's the version where you don't have to write any code, and there's the version where we do everything from scratch. This one's kind of in the middle. It allows you a lot of customization options, but also saves you a lot of time. Now, let's say that you wanted to take this device, here, let's remove power really quick. Let's say you wanted to take this device and actually make something that isn't shaped like a brick, that isn't shaped like an Arduino. That's fine. What you would do is you check out my other videos on making boards. You would order one of these little modules right here. And you can basically look on the platform to see what modules are available for the connectivity options that you care about. But basically you can get one of these modules, use the coupon link down below, but then you can basically design your own boards, your own devices, especially if you want to make something sleeker, something more custom, but you also want to be able to connect up with this platform, which will make connectivity way easier. And that's going to allow you to get something sleeker, something a little more cool looking than just a stack of boards on top of an Arduino, and it's going to allow you to get up to speed really fast. And really that brings us to our other option. Really now I'm wondering, with platforms like Tuya Smart out there, is there really still a case for doing things from scratch? Like, do we really ever need to swing to the other end of the spectrum and do everything ourselves from scratch? And of course, if you watch this channel very long, you know that my resounding answer is going to be yes. Because maybe you need to get your power consumption way down to some level that the existing devices that you can order just can't support. Or maybe you really want complete control over the path that your data takes through your own servers, your own service. You don't necessarily want to go through some pre-existing cloud platform. Or maybe, and I actually think this is the biggest one, maybe you want to become an exceptional embedded developer. You want to do this professionally. I mean, somebody had to make these boards and these devices. Somebody had to make this fingerbot. Someone had to write the firmware for it. They had to create the hardware for it. And if that's the path you want to take, if that's your goal is to become really good at this, then you really want to deep dive into the hardware and the software aspects of embedded systems. You want to dive in and start learning embedded C. You also want to learn to make boards. You want to start playing around with different components and different sensors. And of course, you want to learn all the tools, the debugging approaches, and all the different techniques that we use in this trade. But just know that this is going to take time and it's going to take energy. It's going to be an investment because, I mean, let's face it, if I was going to make a video start to finish about how to make my own fingerbot like this, it's going to be like a 20-30 hour video. In fact, that sounds a little more like a course, and maybe I'll make that course or that video in the future, but today I just don't have time for that. But so I hope this gives you a perspective on some of the different options that are available to you as you get into this space. A big thanks to Tuya Smart for sponsoring this video and for sending stuff. For sending toys, equipment, modules, things that allowed me to play around with this to show you some of the things that their platform can do. Please do check out their IoT platform. Also, like the video if you enjoyed it, subscribe so you don't miss next week's video. Check us out on Patreon or my recent class I just put up on Thinkific. And whatever your goals are, I hope you got something out of this video, and I'll see you next week.